So in this video, what I want to do is I just want to go through the five basic rules of or properties of exponents, and we'll start off with the product rule. So for example, let's say that we had 5 squared times 5 to the third power. Okay, well, if you were to expand this, what this is really saying is 5 squared is just 5 times 5. Okay, and then this multiplication sign, I'm going to put that right there, and then I'm going to write out 5 to the third. I'm going to write that out 3 times. Okay, so this is actually the exact same thing as just writing 5 to the 1 2 3 4 5, so 5 to the fifth power. Okay, well, if you look closely, what's another way of getting to 5 with just a 2 and a 3? Well, you can just add them. 2 plus 3 is equal to 5. And so that now there's this notion where if you have the same base, and now the 5 is considered the base here, and then this 3 and this 2, these are the exponents. Maybe we should just write that here, right? So we could say this is the base, and these right here are the exponents. Okay, so if you're multiplying, or you're taking the product, which means to multiply, with two terms that have the same base, you can just add the exponents. And so this is what is known as the product rule. Okay, if now we have something a little bit different, let's say we have 7 to the fourth power over, let's say, 7 to the third power. Okay, if we were to expand this, I'm gonna do the same thing I did here. I'm just gonna write this 4 times, so 7 times 7 times 7 times 7 all over 7 times 7 times 7. Okay, now I can see that, well, on top, the 1 7 crosses out on the bottom, another one and another one, another one and another one, and so now I really just have left with a 7. Now I know that there's no exponent here, but there actually is. It's kind of the same way where if we just have the variable x, we know that there's an imaginary 1 in front of it. So it's the same thing here. This exponent is 7 to the first power, since 7 raised to the first power is just 7. And so this would then be 4 minus 3. And so we can say that when we have two terms, or if we have a term where we have the same base and we're dividing, otherwise known as the quotient, then we can just subtract them. And so we have 4 minus 3 is equal to 1. Okay? The third rule, it's pretty important, is let's say we have x to the third, all of this raised to the fourth. Okay? Well, if we were to expand this, whatever's inside the parentheses, and actually I'm going to use an even more simplistic example. Let's say I have 2 to the third. Let's just say 2 to the third, like this. Okay, this is essentially saying that I'm taking the quantity that's inside the parentheses, because notice that this exponent is outside of the parentheses, and I'm taking whatever's inside the parentheses and I'm writing it out 3 times. I'm multiplying them all 3 times. Okay, if I have, let's say, x squared, okay, to the third power, I'm taking whatever is inside this quantity here and I'm just writing it out that many times. Okay, so going back on this piece, we have x to the third raised to the fourth. I'm taking the quantity is whatever's inside of these parentheses. In this case, it's the x to the third, and I'm going to be writing that out how many times? So according to the exponent, I'm writing this out 4 times. And I'm going to try to keep this consistent, so I am going to put them in parentheses, x to the third, right, x to the third, x to the third. All right. Then from here, it actually reverts back to the first rule, which is the product rule. Because whenever you have all of these parentheses laid out together like this, it means that we're taking the product and that we're multiplying. And we know now that if you're multiplying and we're essentially multiplying with the same base here, then we can just add the exponents, right? So this would be 3 plus 3 plus 3 plus 3, and we have x, which is our base, to the 12th power. And now, going back to what we started off with and where we're left off, we can see the connection, and that connection is simply 3 times 4. So when we have a power raised to another power, okay, and it's often going to look like this in parentheses, then we can simply multiply them 3 times 4 to get 12. Okay. The other piece here now is whenever you have an exponent that has that's negative. So let's say 4 to the negative 2. Okay, this is not 4 times negative 2. And we actually don't want to deal with negative exponents at all. So what we do is we kind of like flip it. So I would say create a fraction. Now if you don't know how to create a fraction, you just have to put, all you do is put it over 1, because anything divided by 1, it stays the same, doesn't change it, but visually we can see that now it's a fraction, and then we are going to flip it. Okay, and when you flip it, this will become positive. So 1 over 4 squared, and then this becomes 1 over 16. Or you can leave it as 1 over 4 squared, you know, whatever your preference is. If the numbers are small, I would probably just evaluate it, make it a little bit smaller, or just get the actual number. All right, and then the 0 rule, this is saying that anything raised to the 0th power is 1. So like x to the 0th power would be 1. We can actually just make this on the side here. I can probably show you this y as well. Let's say we have, oh, that's a bad color. Let's have x and then y, and let's say we have 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0th. Okay, well 2 to the 3rd is just 2 times 2 times 2, that's 8, right? 2 squared is 2 times 2, that's just 4, right? 2 to the 1st is just 2, and let's say we didn't know what this one was. Now if you look at the pattern, and math is really a lot of patterns, right? We can say, how do you get from 8 to 4? Without subtraction, we would just divide. Okay, if we follow that same pattern, 4 divided by 2 should give us 2, and if we continue with that pattern, 2 divided by 2 would give us 1. Thus, it leads us to believe now that anything raised to the 0th power is just 1, and that's why we can apply it here. And this works for anything. So if we had like 3, or let's say 32 to the 0th power, also just 1. Right? If the entire quantity, and I say quantity as in like anything inside the parentheses, 3xy, all of this inside the parentheses is raised to the 0th power, that's just 1. Okay? Just don't get confused with now if you have like 3x to the 0, because this is not 1. Because this exponent, that 0 is only talking to the x. Okay? That is only speaking to the x. Notice it's different if we have it encapsulated in a parentheses. We're talking about the whole quantity inside raised to the 0th power, versus if it's just one variable or one number being raised to the 0th power. So this would actually be 3 times, well, this is 1, and then this would just evaluate to become 3. So it's very tricky to really differentiate, and this is something that I know can be a lot of it can lead to a lot of issues. So just be very mindful when you're doing that. Okay, so just to move on to some examples, and I highly encourage you to always pause and try to do the examples on your own. We can do, well, we can start from here actually. Okay, so here we have 4 x to the 3rd times 2 x to the 3rd. Okay, a little bit different since we have numbers here. Now these numbers, right, they have names. These are coefficients, okay? And when you're multiplying the numbers, now notice that these numbers are not the same as these numbers. I mean, yeah, they're both numbers, but they're different. These are exponents. These are coefficients. So whenever we're multiplying, you can multiply the coefficients exactly the same way you normally would. Any of the operations. Okay, so if you're dividing, you divide normally. If you're multiplying, you multiply normally. So 4 times 2 would give us 8. Okay, and then now when we have exponents, that's when we have to use the properties. So this is really going to be x to the 3rd times x to the 3rd. Notice the same bases. So when you have the same base and you're multiplying, you can simply add the exponents. So this will become 8x to the 6th. Okay, so this is just going to be 8x to the 6th. Okay, moving on down here, you have x to the 5th times x to the 3rd. All right, we have no coefficients. I mean, technically speaking, there is a coefficient, and we could put a 1, right? But there's really no need to unless you want to do that. And we have the same base. Okay, we are multiplying, so we can just add the exponents. That would be x to the 8th. Okay, and just because I like to make sure that I'm very visual with it, this is the same thing as having 5x's, right, times another 3x's, and that's how we would get a total of 8x's, which is using that shortcut. of just adding the exponents, right? Same thing here, 2x to the third times 2x squared. Okay, here we have a coefficient times another coefficient. So we're going to treat this the same way we always do. We're going to just do 2 times 2, which gives us 4. And then we're going to just focus our attention here, right? So x to the third times x squared, right? Same base. And we're multiplying, so we're going to keep that base. And then just simply add the exponents 4 to the fifth. 4x to the fifth. And I'm going to just actually, I'm going to show this the long way I did here. Okay, so this is going to the same thing be as like 2 times, now here's 3 x's, right? So x times x times x. And then the big multiplication sign, 2, and then x squared is simply x times x. So if you were to do this, 2 times 2 is 4, and here we have 1, 2, 3, 4, 5 x's. And you'll see the answer is actually exactly the same thing than what we got up there. Right, just a shorter way. Once you know your properties, then you're able to do things a little bit more simply. Okay, all right, so what I'm going to do is we're going to work through quite a few more examples. I'm just going to pause it for now and then start a new video.